Hi, welcome back. So this is lesson 2.2 in our chapter 2 of Unit B, Chemistry and the Environment. And in this lesson, we are going to dive into a little bit deeper the alcohols, carboxylic acids, and esters that we kind of just glanced over the groups. So in the last lesson, we were able to find them, and now we're going to start naming them. So here are your outcomes. Here are your textbook pages. And let's get going. Your video will be there. All right, so you've seen this diagram before. This is on page 9 of your data booklet again. So we're going to step through each of these. So we really actually already did our halogenated hydrocarbons, so we're not going to be taking a look at those again in this section because we looked at those quite in detail in the last one. So let's get on to alcohols. So let's take a look here. So alcohols, we've seen the group, the functional group looks like. It's an OH, or now we're going to talk about, it's called a hydroxyl group. So this is a hydroxyl group. That's the functional group, and this is the classification is alcohol. Okay, so it's not a hydroxide. Don't get them mixed up with the bases. Okay, they're not the same thing. A base, remember, if it's a base, it would have a metal atom attached to it, and these do not. These have carbons, so these have molecular atoms. Anyways, so we have a carbon chain and we have a hydroxyl group here, and this gives us ethanol. So this is an alcohol. We've got 2 carbons, so F for 2 carbons, and then anol. So you're going to start to see, oh well, here we go, methanol. So you kind of see a pattern here, ethanol, methanol. So we drop the E and add OL for alcohols. So we name everything else the same way as an alkane, except we are going to drop the E from the main chain, from the ane, and add OL to it. And we do need to identify where the OH group is, the hydroxyl group, if necessary. So if there's no option on where it could be, then we don't need to do that. So in this case, methanol, meth only has 1 carbon in it, 3 hydrogens around it, and then there's your alcohol group. It can only be on this 1 carbon, so we don't need to number it and say 1 methan 1 or anything like that. It can only be on that carbon, so we just call it methanol. Same with ethanol. If we put the alcohol group here, or if we put the hydroxyl alcohol group over here, it's the same compound if we just flip it over, right? But as soon as you have 3 carbon chain, then it matters where that alcohol group is. And I think, yes, here we have an example of a 3 carbon chain. And you can see the hydroxyl group here, our alcohol. Now, this could be here, this group, or it could be on the middle carbon. And so we need to describe where it actually is. So first thing we need to do is name our main chain. So remembering, going back to our data booklet, page 9, I'm always going back here, and you can see 3 carbon chain, propane. So this is going to be prop. And then, remember, we drop the E, so we go propan, and we drop the E, and we add OL, propanol. All right, now we have to do an extra step in this case because we do need to say what carbon our alcohol group is on. So we've got carbon 1, 2, and 3 here. So our alcohol group is on carbon 1, or our hydroxyl group. And so I am going to just erase our OL, and I'm going to say right in front of where the OL is, which carbon number our alcohol is on. So this is telling me that the alcohol group is on carbon 1. Number 1. Okay. Now, I'm just going to throw this out here. I'm going to add another alcohol group, OH, here. Aha. So we've got 2 alcohol groups. 2 alcohol groups. We need to tell everybody we have 2 alcohol groups or 2 hydroxyls. We're going to use the term di. Remember, if we have a prefix here, if we've got multiple of those groups, branches. So we're going to use di. So I'm adding that in, 2 alcohol groups. And then remember, we have to tell everybody where these 2 alcohol groups are. So we know that one of the alcohol groups is still on carbon 1. And the other alcohol group is on carbon 3. The 1,3-di to tell you that there's 2 alcohols or 2 hydroxyl groups, and then OL is the group that we're talking about. Okay. Example number 2. Now we've got a line diagram. Make sure you remember where all the carbons are. So there's a carbon here, there's a carbon here, there's a carbon here, and there's no carbon there. Yes, let me just check. Yes. Okay, so because there is a group at the end of that line, that's the bond from the carbon here to the hydroxyl group. So there is no carbon here at the end of this line, just to make sure you understand that. So we have a 3-carbon chain here. So 3 carbons again is just going to be propan. If only I could spell. Propanol, but let's say where that all is going to be. We know it's not. We do have to say where that all is going to be because there are other options, right? So carbon 1, 2, 3. So on carbon 2 is the hydroxyl group, propan 2-all. Now I'm going to move my head. All right, let's see what this one looks like. So we have carbon, and then we have a carbon here, no carbon here. So it's a 2-carbon chain. A 2-carbon chain, looking at our booklet, is SN. We know it's all. It's going to be on a carbon. Doesn't matter which carbon in case of ethanol because we can just flip it because there's only 2 carbons. So ethanol is all we need to call that, ethanol. All right, let's do a couple more here. In this case, we've got butane 1-all. So butane means butane. You can look up bute. Bute you'll find here in the booklet. It's 4-carbon chain. So we're going to do a 4-carbon chain. And according to the name, it's got an alcohol group or hydroxyl on carbon 1. So let's call this carbon 1 here, and I'm going to put an OH group here. And that means all the rest of the bonds around each carbon are just filled in with hydrogens. Remember, every carbon has 4 bonds. It already has 2, so it has 2 more hydrogens being added. It has 1 bond, so we add another 3 hydrogens to that carbon. Condensed diagram. So I'm going to draw my 4-carbon chain. 1, 2, 3, 4. And then from my carbon here, I'm going to have an OH group. Hydroxyl. Oh, shoot. I did the line diagram here. Condensed formula. Okay, so we're going to have a carbon with an alcohol group, and then we're going to have the next carbon. Oops. And I have 2 hydrogens on my first carbon. So I need a CH2, then OH group on the carbon. Then my second carbon has 2 hydrogens. Third carbon has 2 hydrogens. And the last carbon has 3 hydrogens. I said 2 and drew 3. Okay. All right, 2-methylpropan 2-all. So let's start at the end. Prop is 3-carbon chain. 1, 2, 3. I know on carbon 2 we have an alcohol or hydroxyl group. So there's carbon 2. OH is there. On carbon 2, I have a methyl group on carbon 2. So it must be up. I'm going to have to put it on here. And then all of the remaining carbons are filled in with hydrogens. Ooh, my light just flashes every time I write. I don't know why it does that. That's really annoying. I think I'm going to have to turn off my camera. Stopping the webcam. All right, that was really weird. I don't know why it's doing that. It's probably been doing that for the whole time. All right, so the condensed diagram is what we're doing. So the first carbon has 3 hydrogens, carbon and 3 hydrogens. The next carbon has a methyl group. Well, I'm just going to use a little line to show the methyl group. If you want, you can use a little line to show the alcohol group. That's fine too. And then the last carbon has 3 hydrogens. Then our line diagram, we're going to have 1, 2, 3, and middle carbon has an OH group, or hydroxyl and a methanol. So we can just leave that because that's a methanol there. Right? Anytime you end a line, like in a line diagram, we know there is going to be a carbon and a hydrogen, 3 hydrogens there. Go. All right, so we just finished alcohols, so make sure you practice. You might even want to pause here and practice naming some alcohols from the booklet. I think I'm going to add a few more videos into this as well, to the presentation for you. So now we're going to look at carboxylic acids. So carboxylic acid, you can see this is called a carboxyl functional group. Carboxyl, like we had the hydroxyl. And sometimes you'll see it written like this, COOH, C-O-O-H, COOH, I always think that. C double bond, so carbon double bonded to an oxygen, and then single bonded to a hydroxyl group, right? Like an alcohol there. So there's some common carboxylic acids that you probably should be able to recognize for sure. Like vinegar is CH3COOH, acetic acid. Citric acid, lactic acid. This is what builds up in your muscles when you're cramping. Citric acid is when you eat those sour candies. Aspirin, it has acetylsalicylic acid, so it's a type of carboxylic acid as well. So they have very similar properties as we looked before because they're all acids. So there's the next page actually shows, I think. So all acids, remember these are their properties. So remember these acid properties apply to carboxylic acid. So they taste sour, they have a low pH, below 7, they can conduct electricity, they're corrosive, they turn blue litmus red. So all of these, because a carboxylic acid is just another type of acid, they all apply to carboxylic acids. Alrighty, so naming carboxylic acids. Actually, I think, yeah, I'm just going to pop over here. So this is how carboxylic acid. So you might have remembered this. So there's your acid. Here's an example of ethanoic acid reacting with water. And the hydrogen here, this last hydrogen at the end of the COOH, is what is going to be donated to the base. And you'll see the ethanoic acid is left without that hydrogen and a negative, right? Because you're donating the proton to the water. The water becomes hydronium ions. So that is how all carboxylic acids react. So there you can see the carboxyl group, and it's this hydrogen, this proton, that is donated to the water. And so that proton is gone, making the carboxylic acid negative. Anyway, that was a little aside. Going back here to naming a carboxylic acid, it's the same as naming an alkane chain, but you're going to drop the E again, and you're going to add oic acid. And if we go back to this chart, you'll see the example. This is the nice thing about this chart. It's awesome. You don't have to memorize everything. You can really use this chart to help you out. Here is ethane. There's 2 carbon chain, and it's an acetic carboxylic acid. So we change the ending to ethanoic acid. Change to OIC. So here is a chain of 3 carbons. 3 carbons is propane, but we know it's a carboxylic acid because of the carboxyl group. So we drop the E from propane, drop it to propanoic acid. Now we don't need to add any numbers here because the COOH group is always at the end of the molecule. It has to be. So it's always on carbon 1. Okay, so this is always going to be carbon 1. So if there happens to be anything else added onto the chain, it's going to be on a higher level of carbon. Here's methanoic acid. Meth only has 1 carbon, and methane, the E is dropped, and the oic acid is added as soon as you add that carboxyl group. Okay, esters. This is the next functional group we're going to look at. What is an ester? This is the next classification of organic compounds. So you can see with the esters group here. So These guys are found in fats, polyester, plastics, soaps. They're also in most flavorings are esters and smells, aromas. Esters have really strong smells, like good and bad, but they are used in flavoring and to produce certain smells. They're formed from a carboxylic acid and an alcohol joined together. All right. This little esterification formula, this is on your data booklet. Okay, that's on page 9. And it shows you that an alcohol plus a carboxylic acid will give you an ester and water. And we're going to see that reaction on the next page. But do you remember that on page 9 you have esters? You have an example of an ester and an example of how it is named. And let's take a look at this naming system. So here's esterification. So we have an alcohol. There's your hydroxyl group. And then we have a carboxylic acid with the carbonyl group. And you can see the OH from the carboxylic acid and the hydrogen from the alcohol are coming off. And that is where you're getting the water from. Okay, I can say it again. The hydrogen from the alcohol, the OH from the carboxylic acid is how you're getting the water. Then your bond is going to form between this carbon in the carboxylic acid and the oxygen in the alcohol. And that is where the ester bond is coming from. Okay, so all esters are going to contain this C double bond, single bond O. So it'll look like Ku like that with no H, all right, in the middle of a compound. It's always in the middle of a chain. You have to have carbons on either side to have an ester. Always found in the middle of the molecule. So from the alcohol and the carboxylic acid, you get an ester. Just a little side here on bioplastics. This is a type of ester. They are completely biodegradable and are made from plants like corn and soy. So you might see these compostable bags. That's what these are. Okay, they actually will break down. And don't end up in the food chain. Like a lot of plastics are not biodegradable, but these bioplastics are, because they're made from corn and soy. And because they're able to be disposable, they actually can use some of these things as like sutures that just dissolve in your body. I actually had some of these compostable bags up in my closet with like old Halloween candies hidden from my kids. And I took them out like probably 10 years later, and I went in and grabbed the bag and it just broke apart in my hand. It was so bizarre. I've never had that feeling before. I've just broke into like a million little pieces, as opposed to if I'd had a plastic bag. Actually, it wasn't a plastic bag, and the regular plastic bag was fully intact because they just don't biodegrade. This is a pretty funny little mockumentary. I would suggest watching it. It's hilarious, on the plastic bag and its life. Okay, so another use of esters is in polyesters. You probably own something that's polyester. Look on your tags of all your clothing, you'll find something. Life jackets, these fabulous suits there, Gary Carson. So polyesters used in a lot of different kind of clothing. A Dacron is one type of polyester where you basically take an alcohol, a carboxylic acid. Again, they bond together, but you do this a whole bunch of times. So the alcohol, there's the alcohol group, and there's a carboxylic acid group. And you'll notice each of these alcohol has another alcohol on the other end, and the carboxylic has another end with the carboxylic acid. So what happens? So you form an ester bond here, create water, you got your ester, and now you still can do the whole reaction again because you still have a carboxylic group here and an alcohol group here. So you create these huge long chains, and that's why they're called poly, which is many ester bonds. Polyester, many ester bonds. And that's what polyester is. All right, so how do we name these? So these are probably the trickiest ones to name, but if you slow down and you think about it, it's very obvious. Okay, so you just gotta take your time. So naming esters using your data booklet again, they always end in O8. All right, so the first you need to do is step 1, find the ester functional group and circle it. All right, so here is our ester group that we're going to look at. There's the carbon, the double bonded O, and the single bond to the oxygen. Highlight each carbon chain that comes off of it. Okay, so name the alcohol chain. Okay, so where is the alcohol chain? Well, this is the end that has the single bonded oxygen attached to it. So there's the single bonded oxygen. So what is the carbon chain attached to the single bonded oxygen? There's only one carbon here. So it's methyl. Okay, so they're methyl in this example, methyl. So you name the chain that's coming off the single bonded oxygen. Came from the alcohol, methyl group. And then step 3, you're going to name the carboxylic acid, right? Which is basically double bond where the double bonded oxygen is. Okay, so there's your double bonded oxygen, carbon. There's only one carbon in this carbon chain too. So this is called methane, meth from that carbon chain. And then you add O8 to the end of the second name. So methyl methanoate is how you would name this guy. Okay, so you can think of it this way. Find the carbon attached to the single bonded oxygen first. Name it, not name that chain. Find the carbon chain attached to the double bonded oxygen. Name it, and then add O8 to the end of it. All right, here's another example. So first things first, find the single bonded oxygen. There's the single bonded oxygen. There's our ester. Single bonded oxygen here. Find the carbon chain. There's 2 carbons. 2 carbon is F. So it's ethyl. There it is. Ethyl. And then we find the carbon that has the carbon chain that has the double bonded oxygen. How many carbons? There's 2 in that. So it's going to be ethane. And then we add O8 to the end of it. Ethyl ethanoate. Do another one here, example 3. So this one, they flipped around on us, so don't let that mess you up. Just find that oxygen. First, find the ester group. Find the single bonded oxygen, and what's the carbon chain coming off of it? There's just a single carbon, so we're going to name that first. So methyl. And then find the carbon attached to the double bonded oxygen. That chain gets named second. 2 carbons is F. Ethanoate, and we just add the O8 to the end. So don't let the flipping mess you up. Okay, don't think you're always naming it from left to right or right to left. You always just find that single bonded oxygen and what carbon chain is on that. That's what's named first. Alrighty, so let's think about this. Here is another way of thinking about this. If you are given the alcohol and the carboxylic acid, how do you come up with the ester name? Well, remember, I'm just going to go back a couple pages here. Here we go. The alcohol is where you're getting the single bonded oxygen, the chain of carbons from the single bonded oxygen. So we're always naming the alcohol first, right? And then the carboxylic acid makes up the second part of the name. So alcohol first, alcohol, so the S makes up the first part of the name, ethyl. The carboxylic acid chain makes up the second half of the name, ethyl, methane, and remember we change it to O8. So the first part of the name is from the alcohol. The second part of the name is from the carboxylic acid, and the O8 is just added to show that it's now an ester. And we can draw this diagram. So ethanol or ethyl is 2 carbons, so 1, 2, and it's attached to the single bonded oxygen. And then meth is just 1 carbon, and it is on the other side, and it contains the double bonded oxygen. There's only 1 carbon because it's meth, and meth only has 1. So then we fill in the hydrogens. So this carbon already has 3 bonds, so there's only 1 hydrogen left. These carbons each need 2 more hydrogens. Actually, this one needs 3. And oxygen already has 2 bonds, and the oxygen there has 2 bonds. So you're done. So now let's go backwards. So here we have an ester. And the ethyl, remember, the first part of the group always tells you about the alcohol. And the alcohol is F. F is 2 carbons. F, instead of ethyl, it's ethanol. Okay, so we change it to the alcohol name. Then the second part of our ester is always our carboxylic acid. So this is ethanoic acid. The carbon numbers aren't changing here. And then the structural diagram. F is 2 carbons, so we've got 2 carbons, and then our ester group. And the other side of our ester group has a 2 carbon chain as well. There you go. And then just fill in your hydrogens. And all right, now we've got a new alcohol. We've got propanol. And remember, we always start our ester with the alcohol's name. So we're going to have propyl, and then ethanoic acid is the second part of the name, comes from the carboxylic acid. So propyl ethanoate. Ethanoate. And how are we going to draw this? Well, we're going to draw our propyl, which is 3 carbons, 2, 3, and then draw our ester group. And the second chain is F, so it's got 2 carbons in it. There you go. And then just fill in your hydrogens. So there's 3 hydrogens there, 2 hydrogens here, 2 hydrogens there, and 3 hydrogens there. Alrighty, and this just, again, just explains what we're doing. So these are some of the references that I use. So I thank them for letting me use their resources to create this presentation. Make sure you practice this, especially the naming of esters, and ask your questions as needed.